Welcome back to the chemistry session. We will discuss electrolysis of molten compounds, electrolysis of binary molten compound, for example, lead bromide. Look at this diagram. Lead bromide. The formula of lead bromide is PbBr2. In an electrolytic cell, there are electrodes, cathode and anode. There is an electrolytic chamber, electrolyte. Here the electrolyte is lead bromide, molten lead bromide. Okay. Electricity pass through. What will happens here? When electricity pass through molten lead bromide, the molten lead bromide will be split up into Pb2 plus lead ion and Br minus bromide ion. Pb2 plus positively charged lead ion move towards the negative electrode, that is cathode, and the Br minus bromine moves towards bromide ion, turns to bromine moves to anode. Keep this image in your mind. Add lead bromide into a beaker and heat, so it will be turns to the molten form. Then the ions are free to move. Once the ions are free to move, it will be very easy to pass the electricity. Then, because in the molten state ionic compound they conduct electricity, when electricity pass through that, it will be split up into corresponding ions. Take the electrolytic chamber cell, add two graphite rods as the electrode and connect this with a power bank and power battery. Turn on the power pack or battery and allow electrolysis to take place. Once the electricity pass through, it will split up to lead Pb2 plus ion and bromide ion Br minus. Negative bromide ions moving towards the positive electrode, that is anode, and lose electrons and turns to bromine molecule. This bromine molecule is coming out as in the form of brown fumes because it's a gas. Then positive lead ions that moves towards the negative electrode, that is cathode, and gain electrons, and it will be deposited on the surface of the metal. There are two reactions happen, one at cathode and one at anode. What happens at cathode? At cathode, they gain electrons. At anode, they lose electrons. So, there is a reaction at cathode and there is a reaction at anode. Bromine, 2 Br minus, 2 electron, then it turns to Br2. Pb2 plus receives, gains 2 electron to become Pb. This is anode reaction and one is cathode reaction. Next example, molten potassium chloride. When you pass electricity through molten potassium chloride, it's split up. Potassium ion and chloride ion. Potassium ion K plus, that moves towards cathode because cathode is negatively charged electrode. So positively charged ion, potassium ion, that moves towards the cathode, and negatively charged ion, that is anode, that moves towards positive electrode, that is anode. Potassium chloride, first of all we want to heat until it to be molten. Once it is molten, then it is allowed to conduct the electricity. Then the electrolysis happen. The molten potassium chloride split up to potassium ion and chloride ion. There is half equation. Anode reaction and cathode reaction takes place. 2K plus 2 electron to form K. 2Cl minus 2 electron to give Cl2. Potassium ions gains electrons. Gains electron is reduction. Reduction is gain of electron, and to form potassium atoms. Chloride ion lose electrons, that is oxidation. Oxidation is loss of electron to form chlorine atoms. The chlorine atoms combines together to form chlorine molecule, that is gas. Look at this diagram. Electrolysis of molten potassium chloride. First of all, you want to draw a cell, molten KCl, electrodes are there, then power supply, electricity pass through that, anode reaction, cathode reaction. When you add both half cell equations, then you will get the overall reaction. Check your knowledge now. The electrolysis of molten potassium chloride. Liquid potassium is produced at 1 electrode. It indicates the reaction K++, 1 electron gives K. Which electrode this? Anode or cathode? Chlorine is produced at other electrode. Is this electrode anode or cathode? Check yourself. Okay. I will give you one assignment. Electrolysis of molten lead oxide. What will happen when electricity pass through molten lead oxide? You just want to complete. Once you complete, check your answer with this slide. At cathode, lead ion accepts 2 electrons to form lead atom. At anode, an oxide ion release 2 electrons to form an oxygen atom. 2 oxygen atoms combines together to form 1 molecule of oxygen gas. That's all about electrolysis of molten binary compounds.